This presentation discusses how solids change in size, length, area, or volume. When the temperature changes, all solid expands when heated and contract when cold. The amount of change depends on the material type and the temperature difference. Example, metal bridges expand slightly on hot days and contract during cold nights. Introduction to thermal expansion. Thermal expansion is the tendency of matter to change in shape, area, or volume in response to a change in temperature. This means when a solid is heated, its particles move faster and push each other apart, increasing the solid size. Next, it occurs because particles in a solid vibrate more vigorously when heated. When heat energy increases particle vibration, which creates more space between atoms. Lastly, this causes an increase in the average distance between particles. Here, this microscopic change leads to a microscopic expansion. Linear expansion. Linear expansion refers to the change in one dimension or length of a solid when temperature changes. It means when a rod, wire, or beam is heated, it becomes slightly longer. Example, a brush stroke is 1.9 times 10 raised to the power of 5 is 1 meter long at 30 degrees Celsius. So the formula here is change in length equals coefficient of linear expansion times original length times temperature change. Here, the change in length is 1.9 times 10 raised to the power of 5. The coefficient is 1 and the original length is 80 degrees Celsius. The temperature change here is 30 degrees Celsius. So let's solve. 1.9 times 10 raised to the power of 5 times 1 times 80 minus 30 is equal to 0.95. So the bus rod expands by 0.95. Next, superficial or area expansion. Area expansion refers to change in surface area due to temperature. This happens when both dimensions of flat surface expand simultaneously. The formula here is change in area equals coefficient of linear expansion times original area times temperature change. So our example here, a square metal plate of side 2 meters at 25 degrees Celsius is heated to 125 degrees Celsius. Let A is equals 1.2 times 10 raised to the power of 5. So 2 times 1.2 times 10 raised to the power of 5 times 4 times 125 minus 25 is equal to 0.0096. So the plate's area increases by 0.0096 meters squared. Cubical or volume expansion. Volume expansion refers to the change in volume of a solid's due to temperature. This occurs in three-dimensional source like cubes, spheres, or blocks. The formula here is change in volume equals coefficient of cubical expansion times original volume times steel, and the coefficient of area expansion is 2.4 times 10 raised to the power of 5, and the coefficient of volume expansion is 3.6 times 10 raised to the power of 5 or degrees Celsius. This relationship helps in converting between different expansion types. Applications of thermal expansion. Railway track has more gaps to allow expansion in summer. Even without gaps, rails could vacuum in hot weather. Next, power lines sag more in hot weather due to expansion. When conductors expands with heat, increasing their length. Bimetallic strips and thermostats use different expansion rates of metals. This means the strips bends when needed and helps regulate temperature. Last, bridge includes expansion joints to avoid structural damage. It means joints allow sections to move freely as temperature changes. Solid expands when heated and contract when cold. Expansion depends on the material and temperature change. This means the expansion amount depends on material and temperature. Linear, area, and volume expansions are related through three forms of expansion is linear, area, volume are interrelated. Thermal expansion has many engineering and everyday applications. This means